Hello, fellow Haskellers, and welcome to Haskell Mask, the season finale! Ooh, exciting! Oh, I don't see Torsten's face. How come? All right. So, thank you for your patience. Torsten, we were having a very interesting discussion before we started the stream about the relationship between GitHub Copilot and our project, which seemed very similar to me before our discussion. Maybe we can summarize it for the benefit of the audience to explain how what we're doing is different and hopefully better.
Yeah, we can do that. So I have GitHub Copilot installed here. I was able to participate in the demo. Okay, so I think it's just covered now by your face, but half covered by your face. But there's this plugin button down there. And what that means is you can get recommendations or predictions of what you likely are going to write next when you code. And we're seeing one just now. So in line 46, which is highlighted here, so this is light gray or actually dark gray text that has now appeared instead of an empty line. So currently Copilot suggests tokenizer binds to with tokenizer, which is sort of similar to what we have in the line below. I mean, it won't work, but that is not completely out of the realm of possibilities, I guess.
Yeah, at least it doesn't
what you can do is
try to do a field access like an OO or something. it does understand the structure of a Haskell program. That's already a good start, I think.
Yes, I mean, look at what it does, right? So for some reason it says let IDs _ equals get IDs. When I'm actually I have used this now for a couple of weeks, and I'm not sure actually if it only takes into account anything preceding your current cursor position, or if you actually passes the whole thing, even what's below, and incorporates this into its predictions. Because sometimes I feel like it becomes the smarter the further you go down in your file that you've opened, right? So if you sort of start using it at the top of the file, it sort of is like a newborn and doesn't understand anything at all. But if you go to the very bottom, it sort of is the master of the universe. So it sort of learns from your context. And it seemed like, to me at least, sometimes it's only unidirectional, right? So it goes in the direction of your writing, what it perceives.
So
but here
because
it seems
your file began
sort of
empty and you filled it up with information, even if it's already full, if you ask it to autocomplete something at the beginning, it's not going to be good, but at the end it is.
Yeah.
Okay.
So I think I've seen demos of people using it with a completely empty file and then expected it to sort of write Python immediately or something, probably based on the file extension. I'm not even sure if it looks at the file now. But here I think, because there is a little bit of Haskell in this file, the language extensions, there's a module description, declaration, imports. Probably has figured out by now at this line 47 that it's supposed to generate Haskell. And now it makes this prediction. So I'm not sure what to think of this. I'm not going to accept it, so I just press escape and it's gone. But if I'm going back there, comes back, and I could accept it with tab. But you can see it doesn't make sense, right? So this variable is not in scope. If it was, it wouldn't make sense to apply get IDs on the tokenizer, because just 3 lines below you can see that it has to be applied to an encoding, which is a different type. So yeah, that wouldn't work.
So there's
anyway,
a lot of room for improvement.
Yeah.
What makes us think that our version will be better?
So right now our vision is not doing much, but we're actually at the crossroads of 2 different paths to something that could work.
Either we can do GitHub Copilot and complete code based on the tech that was previously, and hope that we do a better job at generating code which is both type correct and type checks, or we could re-rank existing suggestions from somewhere else that are already known to type check, but we can use the model's understanding of the context to rank them and to pick among all of those completions with type check which one would make most sense.
Yes, that is exactly what we could do instead.
Mm-hmm.
So both of these options are quite involved, to say the least. But what we could do today is we could just play a bit with what we have and what we actually like. I mean, we're quite close to achieving here something, which is so we have this BART model, but we also have a T5 model if you wanted to play with that. So I have them both here. And what we could do is like we could try to write a autoregressive generation from the model. So the way this works is like you give it an input text, right? And then the model is going to produce the first token of the output, right? And then you give
I remember
it
that we give it the input text plus the first token, and it generates the next token.
Yeah.
Oh.
Plus token 0 gives you token 1.
Yeah.
And so on. So see, this is what I meant by it extrapolates nicely. So it has picked up now this pattern that I'm, and it's not correct because
yeah, we want all of the tokens.
Token 0.
But if you fix the first two, will it then figure it out? Yeah. It has picked up the pattern. Excellent. That is definitely something that we could do, and is in fact the thing that we agreed we would do before I started the stream. But I'm now wondering, like now that we just like discussed that we're at the crossroads, and since I'm a bit more interested in the re-ranking approach, if we wanted to do a concrete step towards the re-ranking approach, wouldn't it be even easier? Because then we don't have this sequence of steps with the input text and the token. We just have the input text and a number being how plausible it is. Don't we already have the ability to get this number from what is written already?
Sort of, I guess. We could make such a thing with what we already have quite easily. Okay, so what you could do is like if you had input text, right, and you had a sequence on the other side of the come on, you can figure it out. Yeah. So if you have that sequence, right, you could give both left and right hand side to the model, and that would give you some number, right? Some score. And that score is sort of what we want, right? So because if this was the first candidate for a typed whole, right? And then you had a second candidate, so this would give you maybe I should not use the arrow, so it's just a vertical line. So this gives you score 1, right? And then you have another example, and this gives you score 2. Maybe they have different lengths, and then this needs to be length normalized. But basically, what you could do is like if score 1 is larger than score 2, you probably want to prefer this prediction over the other one, right? That's possible.
And does it seem?
What I don't know is but we cannot really do anything with this right now, because the only thing we can test this with is English text, because that BART model here has only seen English and not much in terms of code. So we could try to see if you give it an input and an output, basically exactly what we already have here.
We could compare hello, this is a test, with hello world, and see which of the two are the most likely completion to hello blank. But we can't do the same thing with some Haskell code yet. Okay, okay.
And this length normalization thing is a bit tricky as well, because to me it's not entirely clear what the right thing to do here is. If you have two sequences that you try to sort of rank against each other and they have different lengths, then if you divide the score by the number of tokens, I'm not sure if this puts these two scores in the same scale, right?
That settles it then. If it's not even clear to you what it is that we should be doing, then that's too complex for one stream session. Let's do the thing we said we would do, just the auto-generative sequence thing. Yeah.
Okay. So then we would basically implement this here. Right.
Mm-hmm.
So what do we need? So what we have currently is we have a mechanism. Oh, if you look at this script here.
Yeah, I remember that we had to hard code a whole bunch of things. So we need to not hard code them and then add a for loop around it.
Yes. But just like for the audience quickly, so like we're starting here with an input to the model, then we're loading the model from the disk. And we sort of, this is a raw structure here, the state dictionary. But this is then being assembled into a model structure that we can make use of. This thing is not useful, but this one is. And then we're calling this forward function on this input here, which turns out to include this input and the decoder input. And then this gives you some output, which has a certain shape. And last time what we did is we wired this up in such a way that we were able to look at the last position. So if you look at this output type here, there is a decoder output here, which has one item in a batch and 9 sequence elements, and then has for each one of these 9 things that has 50,265 token probabilities or logits. And we're trying to figure out what for the last position, so the 9th one here, is the highest number in this 50,000 dimensional list. And in order to accomplish this, we looked at this last position, sorted them in descending order, I believe, and then pulled them out somehow. I think actually we got more than one. We just got them all and decided then, decided then to take only the last 10.
Can you scroll up? Yeah.
If you do that, yeah.
Well, it's just so that it's hidden by your face.
If you do that, yeah. I wonder what I can do now. Where should I put the terminal? To the right or to the bottom?
What I usually do is I add something to the bottom, just so I know where's the cutoff point.
Maybe if I split it in half like this, does this work?
Yeah, your terminal is a lot more functional than it is when I am resharing your terminal via the VS Code live share plugin.
So I have to comment this block here because it interferes with the compiler. But now I have to recompile this, so I can run now. Let me actually run these things in order. So there's test bar input, and this is basically just printing the inputs here. So like it tokenizes this, hello, this is a test, and converts this into sequences numbers. And this is then loaded into a torch tensor. And we do the same with these decoder inputs, which at the moment, I mean, I tested this just before just to make sure that this still works. Hello, this is a test, so I use the same sequence. And then if I call this function test forward bars, a bunch of things will happen. So first of all, it just prints out these sequences again. Then it gives me some sort of debug output for this step here, which is assembling the model from that state dictionary. So it basically tells me all the things it finds and puts into the structure. And then finally, it produces this thing here, which is, I believe, the output of stuff. So stuff is the back transformed or detokenized array of 10 most likely options. But right now it's a bit weird because
there's no mask. So
we've
end
got
of
the
sentence
case here that
is the
there's no
most
mask.
common.
So it's end of sentence, so anything can go here basically. And
yet it thinks that the
also don't
most
see
likely is yet another end of sentence.
Yet another. Yeah, I would. We also don't know what the total or like the total scores are here. They could all be very low, right? So like it may all be crap sort of predictions here, and I guess that would make sense. But yeah,
if you
so
replace
like
this if you replace test with mask.
Oh wait a minute. So like I have to replace it up here, I believe, and then this is a nothing, and I have to count tokens now.
And maybe now would be a good time, instead of counting tokens manually and hard coding it, to add some code to count the number of tokens, because that's what we will now need to do. We want to not hard code things so that we can increment that number.
Right. I was just trying to see if I can get it to work. So this is 1, 2, 3, 4, 5, 6, 7, 8. If I run this again to that thing, hopefully it will say test. It says exception. Oh, and this is clear because I have this unit test in between the lines here. Let me remove this. Yeah, so I mean, last time we sort of undefined. No, undefined will throw pure. Let's use this. So this shouldn't throw anything anymore. Okay. This is a good. Oh, okay. I guess test is not really that common when you start with hello. This is a. So what we're seeing here is that the model thinks like any of these 10 words could make a good continuation of the sentence. Hello, this is a. Which is a bit surprising.
But it's a very good example, because it thinks that it's a good, but like now clearly the sentence is incomplete. Like this is a good time, or this is a good example, or something. So I think we can keep this example for our auto-generative implementation. So what would be the places that we need to change so that it's not hard-coded? You just counted the tokens. There were 8. So where in the code do we hard code 8? I see an 8 on line 65, but I forgot the meaning of the code. So I'm doing just like GitHub Copilot here and doing pattern matching. That's really not good.
So there are two aspects to this. One is, so this is the number of batches. So we have here a 2-dimensional array or tensor. The first dimension is the number of batches. Since we only have one sequence, we just need one element there.
Yeah,
unfortunately, the second one is the number of
we'll want to run it
tokens,
like 10 times in a row.
In
we'll want to run it 10 times in a row in order to generate 10 words, but there's a dependency between them, so we'll have to do 10 runs of one batch each. We can't do a batch of 10.
Yes. What was I saying?
Whether this 8 was the one I wanted? We were talking on top of each other, so I didn't hear whether you were saying it was or not.
Yes. Right. So like, so this S size here is a singleton type. So it says that this is has a length of 8, and the compiler just accepts this here. And if this number doesn't match the number of tokens in that sequence, it will just either be truncated or it will be expanded to fit into this 1x8 box. I think it's similar here down there.
I think expansion would work better for us here, so that we don't have to generate a type at runtime, which is possible, but seems overly complicated for what we want to do.
Another option would be to make this unchecked. So we have also the option to remove this type checking here and say this is an unchecked size. So now it's a value.
Ah.
And the length is not checked anymore.
I like that better.
And we could do the same here as well. So now the length of the tensor is not checked by the compiler anymore, and we can change it in an algorithm quite easily. Or we could use some type level computation, I guess. But yeah. So the effect of this is now that our BART encoder output is unchecked in terms of shape. But that is not too bad. I mean, it will still work the same way.
I feel like writing some code now.
Program.
You said earlier you could.
Then yeah. So how about can you control the screen? And yes. Ask for control, and I can give it to you.
Where's the button to ask for control?
Or I can just give it to you. There. Now you control. Oops. I think we went to another file. There.
Okay.
How does it look?
Control.
Oh,
great.
wait.
So, where's the code we were looking at? That's too low. I don't see the code. Okay, here is the code we're looking at. So this number 6 is the number of tokens here. We've used encode to convert the string into a number of tokens. So we should be able here to use the length of the encoding. Apparently not. Integer with int, that's easy from integral.
So encoding doesn't have a length, I think. It's a pointer basically. You better use IDs.
Okay. Well, in that case, I don't need the from integral. What do I still do? Okay. Okay. But how do we know that this is the sentence we want? We don't, because what we'll be doing with the auto encoding is not to add more text to this, we'll be adding more tokens. So I think this needs to be moving much higher up. Presumably here. I guess that's the initial encoding of like what we have at the very beginning. I don't like the word initial encoding because it reminds me of F algebras. The prefix encoding, input encoding.
Yeah. You can call it a prompt if you like. This is what people sometimes call it. And while we're at it, I might as well parameterize the whole function by a prompt. Is this called somewhere, or can I change its signature to take a string as input? It's only called below, so you will just break the code in the module.
All right. So we have the prompt encoding, and it has a length. And that is not the length that we want to use here, because by that time we will have added some more tokens. So I don't want to do the for loop left yet.
So one thing, so like would change the BART input code, right? I'm not sure you wanted to do that, but that maybe is a detail. I'm not sure because
the prompt will be hello, this is A. And then we'll have to add mask and end of sentence here, and we'll want to add nothing here, and then eventually we'll want to add a bunch of tokens in between. So I do think that I want to do it like before this, but I might need to do it in the color of those two functions, because I now see that prompt encoding is not going to be in scope here, down there.
Or, I mean, you could inline the whole thing. I don't know how. So one thing I would suggest is that you prepend that sentence beginning token to your prompt, because this is probably something the user won't think about when they calling this function. So if you leave this out, the model may still work, but the behavior is a bit undefined. Well, I guess for the deep learning, the model behavior is always undefined, but it's more stable when you add this thing. Okay, so like, I guess what you want is like in the encoder portion, you want to put hello, this is a mask. Like, so you want to okay, autoencoder. Sure.
Because you were suggesting to merge the two functions, right?
Yeah, I was sort of suggesting this. Right, and then so you want to have.
So we have a prompt. I'm encoding it. I probably need some IDs in order to know how long it is. And now I want to generate this sentence, but with possibly a prefix. So not a prefix, like what has been generated so far, I guess completion?
I'm confused what you're doing there, but okay, I'm gonna watch it. So you're using Copilot right now.
Yeah, I'm realizing it. It is exciting. Okay, so I want for now for it to just be the empty list. I want to be prepared to generalize the code later with the for loop. Okay, so I need to know what is the ID of mask and end of sentence. It's always going to be the same, so we could hard code it, but I could also just ask the tokenizer to encode mask and then end of sentence separately.
Mm-hmm.
So let's just do that as the very first thing. I expect mask token end of sentence token with a letter. If I ask it to encode something, and oh, it's a effectful action, so not a let after all. And I don't have a list of tokens as you've discussed earlier. Tokens, I'll need to convert them to IDs, and then I'll get a list which I'm expecting to have length 2. Get IDs tokens. Let's get a better name than just token. Special tokens. Okay, so that's the first part where I encode just mask and end of sentence. I get the two special tokens, mask and end of sentence. Then I take the prompt, I encode it, I get the prompt IDs. And where do we use those IDs? Here. The length of the prompt IDs, which are no longer computed this way. And wait, no, prompt IDs plus the completion ID. So how would you call, like, what's the difference between the prompt given by the user versus the prompt that has been extended by a few tokens that we've generated so far? Is there another common name for that intermediate prompt?
I'm not sure what you. Can we maybe write this down quickly? So what are
Sure.
the questions now? Because
So
I'm confused myself now.
we have prompt
wanted
IDs.
those decks.
I now want something else like intermediate IDs, which is going to be the prompt IDs plus the completion IDs. And I'm going to use that here and here because I want to ask the question not to get the very first word after the prompt the user gave, but the next word after the prompt the user gave and the words that have been generated so far in the auto-regression thing.
Mm-hmm. So what is completion IDs? Oh, it's up there. I see it now. Yeah.
Currently it's empty, but it's going to grow over time.
Right. So what is this thing in the middle then? Do we need this?
The thing in the middle is, I do think we need it because it's there's two inputs, as you always remind me. The input to the encoder, the input to the decoder. So we need one that is the intermediate IDs plus mask and end of sentence, and one without. Mm-hmm. So I should move this higher up.
So this prompt encoding, this is actually what's going into the decoder. So this is the first thing that the decoder sees. So you probably want to move this stuff above line 60. Yeah, encoder IDs. Mm-hmm. Yes. Mm-hmm. Mm-hmm.
Encoder. And here is the encoder. Whereas here it's the decoder IDs, and here as well. All right, but I don't have a string yet. Now this will give me nothing because I haven't saved the result of this action somewhere because I merged the two functions, so that function was previously returning something, but I don't know what it was returning.
Mm-hmm.
It's something on which we can call forward.
Can you do me a favor?
Sure.
Can you do me a favor? Can you comment everything following line 81, like this whole test forward part base thing? Because I think JC is working very hard to make sense of this thing right now, all the time. And it should not have to.
What am I doing? Have I been programming in
I don't know.
languages other than Haskell recently? No, I haven't. I keep like adding semicolons and stuff.
But this looks like HTML. No. Ah, there we go. Okay, cool. And right, so now we get actually helpful error messages.
So what does make bar input produce? We give it the encoder ID. Is it like
it produces a tensor.
Okay.
It's producing just the tensor from that list.
Sir. And here we'll get a decoder tensor. And now we need to call forward combining those two things somehow. So that's we'll be copying some things from here.
Yes.
Well, you told me to comment it out, but now I want basically all of that, don't I?
Well, be careful. So like this line 92 here, can prompt a large type checking computation. And when the inputs are not perfectly lining up, which will probably be the case for us right now, that takes a long time, unfortunately. So this will block JC for a while. So if you could like postpone and like adding this line for as long as possible, that would make sense.
Okay. So let's keep going. So we had input that we obtained by combining test BART input. So we've now named that the encoder tensor. So just let encoder tensor and decoder tensor. That's the whole input. And now, whoa, we're doing this way too late. We don't want to load all of the weights from the .pt file every time through the loop, do we?
No.
So
I'm not sure. Like, is this your hot loop, this whole function, or will this be? Or are you putting the?
Well, currently,
are you going to inline loop somewhere?
I don't have a loop, but I added this completion IDs so that I have something to add to throughout my loop. Maybe we can not care about the loop yet.
Okay.
So it's fine that I'm doing it here because so far I'm only doing it once. What's the line after that? The state dictionary, I guess that's all of the weights. The model.
The model just unpacks the state dictionary. So this, so line 30, what am I saying? 83 to 85, they are unpacking that state dictionary into this model data structure. You can actually hover over model and see if it already works correctly. Cool. And then input, is it anything like line 81? Nope. I guess you need to emit pure or something at the end so that the parser is happy, and then we get compile time information about input.
But it doesn't say anything about the input.
Yes. I think if I scroll up, I will probably quickly find the error there. That was the error. There were exports that didn't exist. Okay.
Okay, so now I see a whole bunch of red lines. What?
Yeah. So, can you still control the screen?
Yes.
Yeah, good.
Okay, okay, I know it's not in scope. It's tokenizers dot get IDs. Probably have that a couple of places.
Oh, for some reason the D is capitalized in get IDs.
Okay. And then not used to Visual Studio Code, so all of those pups that are trying to be helpful are just getting in my way. Variable not in scope encoding, yeah, because it's the prompt encoding.
It's all on fire.
And then I'm using completion IDs right here. Completion singular. And then I called it mask tokens, but it's an ID. And for consistency, I guess I'll use capital D as well. And don't think I'm going to use mask and end of string separately from each other. So no reason to risk using a partial pattern here if the mask or the end of string happens to be encoded using more than one ID, which I don't think is likely to happen, but there's no point in being more partial than you need. So mask end of sentence IDs, and now use a lowercase d, to be consistent with the other convention we've used in the same file. And here, yeah, I add the mask end of sentence.
Oh wait, actually this is not correct what you're doing there.
No.
So the encoder IDs are stable. They will never change. So you need to use, I think it needs to be the other way around. So encoder IDs will always be prompt IDs plus mask end of sequence IDs. And then the decoder IDs, they will grow.
Wait. The encoder is the prompt plus the mask. And then the decoder is the encoder IDs plus the prompt. Plus the completion. Okay.
Not quite. It's also prompt IDs. It's also so it starts growing from
right. I don't want to include the mask nor the end of sentence. Okay.
Now you have completion IDs twice. What happened there? I think the copy paste didn't work.
Let's try again. There we go. Okay, next from integral completion singular, but I don't need intermediate anymore. I've just named it above. And I'm not using the input yet, but that is fine. I'm about to. Okay.
Okay.
Let's call forward.
So let's see. Let's go forward here.
So that's the line you were scared about, right?
That's the line I'm scared about. Okay, it looks good.
Already? Okay.
Seems to work. Because otherwise, yeah. Like, it's done. Like, there's no spinning wheel. It's done.
So it only takes a long time when things don't type check.
Yes, and I have tried to debug this, but I'm not very far into it.
It reminds me
really
of
weird.
the classic GHC bug where they are deleting your file if your file doesn't type check. You're punishing your users when they write code which doesn't type check with a slow compilation time. But all right, it does type
Something
check.
like that, yeah.
We can move on. Okay, so
and
well, I guess I can just implement the rest because it's not scary anymore. Okay, so what were we doing with the output? We were extracting it into a tensor, a list of float. And okay, so the outermost list is because we can have many batches, but there's only one. So might as well hard code it here. I expect that there's only one. We have to be partial here anyway. And then the second, like the intermediate level, not outermost, not innermost list, is, what is it? Is it all of the token positions? Okay, so we know exactly which one we want there. We want the one at the position that is one more than the length of the input.
right.
Will it
so,
add it?
If you look at line 97, we already have that code, right? All of it. So this is the last logic thing, I think.
Okay, so undo. Here we're taking the first batch. We're taking the first 3 positions. I don't know why we want that.
This was just for testing. I think lines 88 to 94 can go into the graveyard.
Right?
Yeah.
So that's the same thing as the lines above? No, that's decoder. Because we don't need to check the output of the encoder, only the output of the decoder. Okay, so First batch, last position. Yeah, because okay, so there's no padding. I want one more than the size of the input, but that's also the last one. Where did we say how many tokens we wanted for the output of the decoder?
We always get one. It's one additional one.
Okay. Well, I know that we want one. I didn't know that the model was already hard-coded to produce exactly one. Okay.
That's the only thing it can do.
Okay.
It can only do one at a time. I mean, it produces all the old stuff plus one extra.
Okay.
At each step.
So in that case, if we were to do the re-ranking approach, it would still, in addition to telling us how likely it is that the current input is, it would also give us an extra token?
To do that, I suppose, yes.
Okay.
But presumably all our sequences that we're going to rank are completed. And so there's no value in producing yet another token.
But it's the only thing it can do. So it will produce an extra token even if we don't need one. And in fact, that's what we did
it will
earlier.
Produce something.
Earlier, you gave it an example with the hello, this is a test, end of sentence, and there was no mask, there was nothing to complete, but it still thought, well, maybe there's another end of sentence after the end of the sentence. Okay. So, last position, and then comparing down in order to... well, back then we were interested in all of them because we were debugging. Well, we might still want to debug because I've written a lot of code.
So maybe still want to debug.
Run what we have so far, and if it type checks,
there was so that function reverse there.
What is there?
So there's a bug in the tokenizer. There's a bug in the tokenizer. Maybe you remember this. So whenever it sees token 50,108, the Rust backend throws an exception that cannot be caught. So in order to exclude this, I have this weird case matching there. Okay, you want to remove this?
Well, this entire block is within the scope of a tokenizer, no? It's here.
Oh yeah, you're right. You're right. You don't want to nest those.
I was just trying to be economical. Something bad can happen if I create another tokenizer?
Probably not. But I've from experience I know that the thing is not thread safe. So you like in another project I had to add like a semaphore so that only one thread can use it at the time.
Stuff is not used, so the filtering we did to remove 5018 is not doing anything.
Yeah, I think we had just a print somewhere that's now gone.
Okay, so we're not filtering it, we're just hoping that none of the first three most likely are going to be 50108. Maybe we can just filter it out.
Yes. We could also filter it out, I suppose, which is safer, because that token is useless anyway. It's basically empty. So the problem there is that the token itself is the character to terminate C strings. That's why this is crashing.
So I can filter it over there, and then I don't need to filter it here. Okay.
Oh, but now you have removed the detokenizing completely.
Oh, have I?
I guess at the very end, it's gone now. At the very end, you wanna detokenize the whole sequence, no?
Yeah. I thought I had deleted code in which you were doing more comparison tests between the numbers that you expected and the numbers we got. I guess I could press Control Z a couple of times to recover it, but maybe it's easier to just write it.
Wait a sec. So I'm talking just about this thing here, right? Tokenizer. I mean, I guess we can. Yeah. So like, I don't know. Just let me put this down on maybe down here, so that we don't forget that there's tokenizer the decode function that we want to call, and I think now this can go back to nowhere. Okay, and I think what's following is also useless. 92 to 96. We don't need that either.
92 to 96 is, yeah, it duplicates most of the last logic for some reason. Okay, so now we have last logits plural. We're only interested in the very last. So last logit equals the first element of the list that this do block is generating. It's partial, we have to. And then, so that's going to be an ID that we need to convert to a token and then to a string.
Wait a minute. So what is this returning? Can you hover over this? So this is an integer.
Int, yeah.
So wait. So we zip together. We zip together the scores. So this must have been floats with things that count from 0 to 50,000 something. So this is our index. So you can call this actually last ID. This is not last logit. This is last ID.
Great. Okay, so I don't remember the difference between an ID and a token.
The token is the string, the ID is the index of the token string. So they come in an order, and you can think of this as an int map, and we're looking at IDs as the integer keys and the values as the token string.
Okay, so maybe token was not the right word. So here we are starting from a string, we are converting it into an encoding, which in my head was a list of tokens, but I guess I was wrong about that. And then we are taking this encoding and converting it into a list of IDs. So now if we want to go in the opposite direction, from a list of IDs to a string, then I guess we need to go to an encoding first.
No, that goes, well, I guess it's inconsistent, but...
I remember, because different people wrote it, yes.
That. Yes.
So in that case, decode, tokenizer, a list, right?
But remember that you don't have to do that, right? Because you only, I mean, in order to generate, you just like use the IDs. You don't have to go to strings until the very, very end.
I agree, but
after you loop.
In this version, there's no loop, so I'm already at the end. So I want the decoder IDs. Do I not?
Okay. Yes. Yes, you want.
But it's already in such a complex format with like the list of floats. So maybe instead I can take the input, which I know is the same as the output except for the last one, and just add the last one we've just extracted. So do I have encoder IDs somewhere? I think so. It's just hidden by the helpful pop-up. Here it is, encoder IDs.
Oh, why don't you use the decoder IDs?
Yeah, decoder IDs. My mistake. Okay.
Right.
Can we run this?
Should work. Yes. What is the name of this function?
Test BART
Test BART
autoencoder.
autoencoder. And it's not exported, so that's why I can't run it. That's no problem. Okay, so let's see what. No instance for show string. What?
Well, because I added a string input, so
yeah,
we need to give it the
an
string hello this is. Should be hello this is good. Hello this is D, good enough. But why is it different from before? Before it was hello this is good.
Oh, because I said hello this is A, I think. Let's say this is A.
I agree that D is more likely
it's different.
than A.
Why is this different?
Yeah,
though?
it is different.
Huh.
We were taking, remember, we were taking like the top 10, right? Maybe they are ranked from 1 to 10 instead of from 10 to 1. And so while we saw the list, good, blah, 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 problem, maybe it is indeed problem, which was the most likely?
Yes. Can we check that the ordering is correct? Yeah, well, I mean...
Can we take a string with a known completion from BART?
Can I do one thing before we do that? I'm gonna just return the tuple. Last ID, last logit. We don't want to have the fmap here.
So a logit is a probability number?
Yeah. And maybe not the head, but then I want to see at least two, right? So that if they're ordered. How do I do this now quickly?
Do the head now, run it, and then do like
do again,
head of tail.
Oh, I didn't compile? Okay, so this is 886.
Which seems like a reasonable number, not like something to the minus something.
Okay.
8.7 instead of 8.8.
So this is a new.
This is smaller.
So it's a bit smaller. So let's see. Okay, again, new. This can't be right. Oh, it didn't compile. This is a question. Okay, so how many of those do you need until I have 10? 3, 4, 5, 6, 7, 8, 9. This is a little. Okay, I don't know what's going on, but at least there's something that's reasonable. Maybe what actual problem was that maybe this number was incorrect, the size, and got somehow truncated. But I guess now it must be correct now because we're not counting manually anymore.
Because we want to output one more token. Do we need to include that token in the length that we are giving it, or not?
No, because it's one additional element to that dimension.
So since we still seem reasonably confident that the code is correct, can we try it with a string from BART whose completion is known?
That's smart. Okay, so luckily I have this here somewhere.
Well, I'm sure you have the Python implementation of BART. I was thinking like an example from a paper or something, but like sure, if you have the Python version. That works too.
Hello, this is a mask. So let's see what this gives. Output. I was using this for debugging, and I guess wait a sec.
Speaking of
This is
debugging, is
unusable.
there a way to disable the large amount of output that we see when we run this test autoencoder?
And unless there's an override that turns off both compilation project wide,
Okay.
I don't think so.
Okay, no problem. It's just that there's a lot of output and we're not even looking at it. This didn't seem useful, but if it's hard.
Yeah. So wait a minute. I had this open earlier. Now I don't know where it is. Give me a sec. Board, modeling boards. I inserted some print statements. Yeah, this one.
It doesn't matter.
Okay.
It was a small thing.
Okay, so this one will produce output from hello, this is a mask, blah blah. Right? So and this produces hello, this is a good one. And I remember good being one of the first predictions when we ran this earlier, right?
So we have a bug somewhere.
So where did good go?
But it's a weird kind of bug because the completions like made a lot of sense. So it's not like we are returning like the very last number, or like if there is a bug anywhere, I would expect it to be completely wrong, not just a little bit wrong.
You're right. It is weird. What did I actually type? Maybe I typed something that was just very close to what we needed. Hello.
Maybe the
Oh,
space.
here, capitalization.
Okay.
The capitalization. There we go. So it was a capital H. It makes all the difference, apparently. All right. I'm gonna leave these two lines that I hate. There. You're up again.
All right. So let's do the loop now. Like I said, I only want to load the model once. I don't know what this generator is. Presumably I also only want, oh, it's a let anyway. But the forward I didn't want to do more than once. I guess I'll comment it out before I do anything. And what's this I wanted to do? Yeah, move this to the top. Before even we load the tokenizer.
Mm-hmm. That's a good idea.
Okay. And where's this G used? Oh, it's used in the forward. Okay, so I don't see any errors other than. Okay, but I shouldn't be uncommenting it yet. I should be working on my loop. Okay. So
if you just add the pure mempty or whatever you had before there back, I think that function will type check.
Nope.
Yeah, the indentation is probably there. That's probably because of the indentation there. One more. Yes.
Okay. I will need the tokenizer until the end because I want to decode at the end. So the loop should be inside that. The special tokens, I only need to decode them once, so below that as well. Here the prompt encoding, I only need to encode it once. And in here, the completion IDs. No, this part the encoder ID does not change either. So I should reorganize the code so that everything that is outside of the loop is higher up.
Mm-hmm.
And so instead of a local variable completion IDs, I want this to be like an iteration variable or something. Oh, actually, we need to figure out like how many tokens we want to generate. That's a parameter. No, we do it until end of sentence, right?
Yes, the technical term is you want to have oh, now I forgot the technical term. Shit.
Okay.
But you want to have a condition or a set of conditions that interrupt decoding, right? So you want to have
either the length or
criterion. No, what is it? Yeah.
Either the length or
you can specify a maximum length
mm-hmm.
or end of strings or both. That would probably be the best.
Okay, so in that case, I'm going back on my decision not to split the mask and end of sentence token so that I can recognize end of sentence token.
Yeah, good point.
Alright. And well, I need to know the total, the number of tokens. Should I, like, it doesn't seem that useful for the user to be able to specify that, because presumably they want the completion until the end of the sentence. So maybe it's just a, like in case something goes very wrong.
The maximum, the maximum supported by the model is 512. So may as well use that.
Okay. So
if you go beyond 512, you will get the very poor performance.
Okay. Max input size?
That's good.
512. Okay. So now I want a loop.
See,
good guess,
this is
Copilot. But
good
no.
guess, yeah.
Okay, so here's an idiom I like for a anonymous loop in the middle of a block. So that's flip, fix, loop. And I give it both an argument. So with just fix loop, that's a loop in the middle of a block of code where I can call loop if I do want another iteration, or not call loop if I want to finish. But then that does not allow me to have a variable that I accumulate things to. And so flip fix is an idiom that allows me to add such a variable. Like without the flip, so it would be fix of somebody that calls loop. Like I said, I can return a value. So if I'm returning a function, it means I can have another argument here, let's say x, and then after that whole thing, I could apply the fixed function with the initial argument x0. And it's just nicer with flip fix to put the
I use the same for runs. For run state, I use exactly the same thing because it's super annoying to have that dangling thing at the very bottom after a potentially very large monadic block.
Okay, so now I'm in a body where, well, I haven't specified what x0 is. The starting value is the empty list, because that is my completion IDs, which is right here. So I no longer need it here, because that will be, come on, delete. Okay, because that will be the variable here, completion IDs, that we're not iterating over it, but it is an accumulator that we get to add things to throughout our loop. So, well, we don't currently need to do anything to it. We can just run our code from before, including everything which is commented out. So I guess I'll have a stand-in for the expensive line. Oh no, oh no, oh no, undo. I'll write it inside of the comment. So there'll be something that outputs that. I guess it can just be undefined.
Mm-hmm.
Okay, and then I just keep this line commented out, and everything else can be fine. Okay, so I use the input as before, go forward, the decode, eventually I get a logit, and I don't care about the logit, that was only for debugging. But we can still keep it around if we need to debug in the future. But now we do know what is the last ID that we want to add. So let's loop with completion IDs plus last ID, or rather, that's what we would loop with if we are looping. But let's first check. So if last ID is... Oh, good job, Copilot! That is indeed what I want to check. End of sentence. Then I want to return early. So pure of completion IDs, presumably including the end of sentence token.
What's the type of loop?
It's a function from the argument we gave it with the flip fix. So from list of int to whatever we want. That's what we are defining here. Since I'm returning a list of IDs, that's what it will return. So here I can output like all the IDs, output IDs. There you go. Well, I guess I should not just return the completion IDs. I should return what comes before the prompt IDs. Prompt IDs plus the completion IDs plus the last ID. Okay, that sounds good. Otherwise, well, we still have a couple of possibilities. So let's maybe use the multi-if extension. Multi-wait if. Is there a magic VS Code way of automatically adding it, since it clearly knows that?
So you have to go under the you have to go under these squiggly lines, and then click on it, and then open the light bulb and say add multi-wait if.
Yay!
And I'm sure there's also a keyboard shortcut for this, but I'm too old for those. I can never remember those.
All right. So
I should use this. This is a good extension. This is much cleaner than like a nested if block. Cool.
The other condition is
Because typically oh, sorry, go ahead.
no, go ahead. I'll keep typing. It's very
Oh, I mean,
obvious.
sometimes what I do is like I use then weird case blocks because then I get the guards too, right? But with this extension, much more direct. That's nice.
Okay, so I did want max input size. I guess it's tab, not enter. Okay. No, that is not what I want to return. I want to return well, almost the same, just without wait, +1. So 512, that's the maximum input to the decoder or the maximum output to the decoder?
Maximum input to the decoder.
Okay, so if we've already reached the maximum, then I return the same thing that I would have returned.
So the problem is though that the input is shifted right. So like you asked before, like where's this additional token coming from? So there's an additional token that you don't see here. It's not counted because it's added later when you call forward. So I guess that you need this +1 after all, because without it you will be 1 over.
Okay, but it also affects what I'm returning?
The thing is just that, like, if this happens, you don't even want to engage this thing, right? So, I guess I'm thinking of the case where like prompt IDs is already larger than 512.
Oh, good point.
Or longer than 512. So I guess this if block can go to the very beginning of the whole thing.
Well, so you want to check this more than once?
No, just once. So if the last okay, so you cannot check the last ID until you have it in hand, right? Never mind. Like just do it the way you had it before. I think this overcomplicates things.
Okay.
Otherwise.
And turns out I don't need multi-way if after all. Because the two conditions have the same effect. Otherwise loop, yes, yes. And what does Copilot think I want to loop with? Completion, yeah. Yeah, good job, Copilot.
Not sure
I wrote it
if
immediately below.
Just copied from below.
Okay.
Yeah.
Okay, so
do notation statement discarded as a result of type int. Why does it do that?
Because this tokenizer,
because you call it tokenizer,
is accidentally inside of the loop. Variable noise and scope decoder ID is these because now it's the output IDs. Output IDs. All right. And fix is from the decoder function. Import it for me, please. Data function. Here you go. Okay, can I
Okay.
switch this undefined for a forward?
Yeah. Try. Mm-hmm. Uh-oh. Uh-oh.
No?
Not sure. Yeah, I think it works.
Great, can we run it?
Yes, we can. Let's see what happens. Uh, should we take this input?
Yeah, yeah. Hello, this is
Hello, this is a good one.
a good one. All right.
It worked. On first try.
Woohoo!
Amazing.
Ah, excellent. So, is this
Excellent.
good enough? Is this also a good hello? This is a good way to end the stream on a high note and maybe even a good season finale?
Could be, yeah.
Yeah, or is there
Let's try
something
some
else
else
you want to
stuff.
try? Yeah.
So Haskell. Nice. Okay. Amazing.
It doesn't think that the Haskell is the
Haskell
name of a
is
character after all.
Haskell
Haskell is
is
a
a great
great tool,
tool.
I agree. Ah, thank you, Bart.
Wait, which model do we actually use now? We use BART base. Okay. So what
But
you could
how
try quickly
come
is
when we
use the
tried
different
Bart
BART.
before, when we tried to autocomplete Haskell blank, it was assuming that Haskell was a
Yeah.
character from a play. So what's different this time?
Uh, I don't know. Might know that we're using a um, small BART. So this model is not super smart.
Well,
So
it
we
says
could
Haskell is a great tool. Is that bad? It knows how to recognize quality.
uh yeah, do you want to try another output while I'm oh no, wait, you can't because I'm hogging mouse and keyboard. One moment. BART base statement. Oh, right. That's not good. Eh, I'm just downloading a bigger BART.
Okay.
Uh, so
To see
what else
if
can we try? Haskell
the
is
small
not.
Bart thinks that Haskell is a great tool, but the bigger Bart knows better. Mm.
So maybe I should actually get rid of this debug output there quickly. Um, where is the print statement? Somewhere here. Place show. Haskell is not. Haskell's not a good idea.
Yeah, let's
Oh.
get the bigger Bart. This one needs work.
Um, yeah, okay.
So it's just
Okay, so I have to pick
different.
apart.
Wait, it's not. It isn't just a Bart that has been trained for longer. It also has bigger weights, but all of those should come
Yes.
from the file we're loading. I don't think we need to change the code, do we?
We don't need to change the code except for this word here, but large.
Great.
And we also need better tokenizing. But I just downloaded the file. I need to put it in the right place.
Mm-hmm.
One moment.
And can we try a completion of some Haskell code, even though we know that the results are probably going to be terrible, in order to have a baseline for future improvements in which we attempt to do transfer learning from BART trained on the corpus of lots of the internet, presumably, versus to transfer it to Haskell code in season 2?
Shape error. Okay, so perhaps. Oh, there is actually something we need to change. Right, because it says here bought base spec. We need bought large spec. The thing is,
We haven't
I
defined
don't
that.
think I have made one. That isn't difficult there. Oh, maybe it is. Because of all these things here, we have to look them up. Ah. Well, maybe we stay with the small one. It's interesting nonetheless. Bot base. But it's cool. Well, it's fun. Is this all?
So as a last example, can we try to complete some Haskell code? It will probably be complete garbage, but just to use as a baseline for something we'll try to beat in season 2.
What's the canonical Haskell fib? N. I'm not trying to do its Haskell code.
Well, we can give it the beginning of the famous definition of fibs that is like on the haskell.org homepage, and then see if it completes it. Like, I think it's fibs n equals 1 cons 1 cons, and I don't need to remember the rest because we can ask Bart.
Okay, can you type it? Because they changed the example. It's now filter prime.
Not fibs. Fibs, all of the fibs is 1, then 1, then, and it would be like zip with fibs with tail fibs, but let's see what Bart think is the completion. 1, 1, 1.
Another one.
I think we can do better than that. Well, it's not going to be the correct definition, because it, like, how can it know what fibs is? Maybe you can give it a better chance. How about instance functor? What would be an easy type? Identity. Where typically there's a new line, map, identity. Oh, map F. My mistake. Oh, and there are no parentheses. No, there's a variable here. Identity X. Oh, it thinks that the sentence ends immediately. Doesn't see that it's equal to something.
Looks
Let's
like
give it a hint. The sentence probably doesn't end immediately after the equal. Equals F. Nope.
No.
So lots of room to grow, but that's what we expected, because Bart has been trained on text, not on code.
How about I ask Copilot quickly?
Oh.
Copilot says X.
That's not much better.
Okay.
Now X would have been almost correct. It's const X, right? Not const fx. All right. Well, both Bart and Copilot have room to grow, and so if indeed we use completions that are guaranteed to type check and only re-rank them, we're already going to be better, because nothing that has been suggested so far type checks. But yeah, that will be in season 2. A good thing.
Okay, cool.
All right.
I'm gonna just one last thing. The code we've written today, I'm gonna push it. So the whole graduate typed Haskell stuff has actually been merged into master. It lives in the experimental folder there. So people can use it now if they want to. They get all these models there too. What have I done to get actually these checkpoints and JSON files? So there's another project in the HasTorch org on GitHub that is called HasTorch Datasets, and you can use Nix there to sort of get these model checkpoints from hacking phase on the command line and dump them somewhere, which is what I just tried to do with bot large quickly, but was then blocked downstream. Cool. All right, that was fun.
Yes, it was both an interesting, but a fun stream and a fun season 1. Looking forward to try that again at some unspecified time in the future. When we'll both have time again, which could be in a while.
And we'll both have time. Could be a while, yeah. All right. Then
all right.
See
you. See you in the future. Ciao.